Hello. In this video, we're going to look at how we can use factoring to solve quadratic equations. So in order to do that, we're going to first consider an equation in the form AB equals 0. So in other words, something times something equals 0. Now, if I know that the product of two factors is 0, then I know that at least one of those factors has to be 0. Now, if I assume that these factors are different, they might both be 0. But if I assume that they're different, then either A equals 0 or B equals 0. This is a conclusion that I can draw if I know that the product of two factors is 0. This is what's called the zero product principle. This is why expressing polynomials as factors can be quite useful. Because if I consider this equation below, if I consider the equation below, now this isn't technically a quadratic equation, it's actually cubic. But what I have here is I have the product of three factors in this case, so kind of like A times B times C equals 0. But the same principle appears. All three of these factors are different, so they can't all be 0. But because when I multiply these three things together, I get 0, I know one of three things must be true. Either negative 3x equals A, or equals 0, or 2x plus 1 equals 0, or x minus 5 equals 0. One of those three things must be true. In fact, if any of these three things are true, then the whole product will be 0. So a solution to any of these equations is going to be a solution to the original equation. So in other words, if x equals 0, and I substitute it into this original equation, then what I get is negative 3 times 0, which is 0, times 2 times 0 plus 1, which is 1, times 0 minus 5, which is negative 5. But when I multiply those three things together, I get 0. So that original equation is correct. If I solve 2x plus 1 equals 0, I get x equals negative 1/2. And again, if I were to substitute that in, I would get negative 3 times negative 1/2, which is 3/2. 2 times negative 1/2 plus 1, which is 0. That's why we chose that value. And negative 1/2 minus 5, which is negative 11 over 2, all of which does give me a product of 0. So that checks out. And then finally, if I solve x minus 5 equals 0, that means x equals 5. And again, if I were to substitute this into the original, I get negative 3 times 5 is negative 15, times 2 times 5 plus 1, which is 11, times 5 minus 5, which is 0. So as soon as I multiply those together, I get 0. So all three of these values of x are solutions to that original equation. So we can say that x equals, and then we have a set of solutions. So I'm going to indicate it using these curly brackets. And I'm going to write the values in increasing order. So negative 1/2, 0, or 5. All three of these values of x would be considered solutions to that original equation. So this is the basic idea of how factors can be used to solve equations. Two really key elements must be met. My equation has to be expressed in terms of something that is equal to 0. So one side of the equation has to be 0. And the other side of the equation has to be a product. It has to be expressed as a multiplication, in other words, individual factors. So if I look at this next equation, these are not factors. This is something minus something else equals 0. And I don't have a nice little zero subtraction principle, because there's literally an infinite number of possibilities that something minus something would equal 0. Something minus something else would equal 0. However, if I factor this polynomial, then what I'm doing by factoring is expressing it as a product. So when I factor this polynomial, I'm looking for two linear factors that multiply together to give me this 6x squared minus 7x minus 5. So to recall how I would factor, 6 times negative 5 is negative, or 6x squared, so negative 30x squared. And I'm considering what would be two terms that would multiply together to give me negative 30x squared, but would add together to give me negative 7x. So that is negative 10x and 3x. So depending on how you want to do your factoring, I need to just distribute this up. But what I'm going to end up with is 3x times 1, so positive 1, and 2x times negative 5. So I'm just making sure that, yes, 3x times 2x is 6x squared, negative 5 times 1 is negative 5. So these are the correct factors. This now leaves me with something times something else equals 0. So what I know is that either 3x minus 5 equals 0 or 2x plus 1 equals 0. They can't both equal 0 at the same time because they are different factors. But I get x equals 5/3, so that is one thing that would make this whole equation 0, or x equals negative 1/2. If I were to plug either one of these back into that original equation, so 6 times 5/3 squared minus 7 times 5/3 minus 5, or 6 times negative 1/2 squared minus 7 times negative 1/2 minus 5, both of those things will give me 0. So the final form for my answer, x is being chosen from a set of possible values, so using set notation, x is coming from the set that includes negative 1/2 and 5/3. There we go, 2 answers. And let's do one more. In this case, the first condition isn't met. I don't have it equal to 0. So not only do I not have a product, it's not even equal to 0. So I need to start by making sure that everything is over on one side of the equation. So 10x squared minus x minus 2, and it is now equal to 0. And now I need to factor it because I need this expressed as a product and not, as I have here, a difference or a sum or anything like that. So I'm looking for two terms whose product is negative 20x squared and whose sum is negative x. So that is negative 5x and 4x. So the 4x is going to have to come from 2x times 2, that would be positive, and the 5x is going to have to come from 5x times negative 1. All right, so again, we now have a product. I have this factor, 2x minus 1, times the second factor, 5x plus 2 equals 0. So either 2x minus 1 equals 0 or 5x plus 2 equals 0, in which case either x equals 1/2 or x equals negative 2/5. And I will then express my answer as a set, negative 2/5 and 1/2. It's not both of these, so it's not 1/2 and negative 2/5. It can't be two different numbers at the same time, but it is either of these answers.